Hi guys, coming in hot from F20 at Fairfield Road High School. I am here in the classroom collecting my stuff since it's the last day we're allowed to come in, and I thought I would do not a live video but a video recording for you because electron configuration seems super confusing. So I'm going to try to teach you for the first maybe 10 minutes to hopefully clear everything up. It's not going to take that long because you guys already know all the vocabulary that's associated with electron configuration. It's just really hard to put everything together and relate it back to the periodic table. So I'm going to do a quick lesson that I want you guys to watch for today, which is March 24th, Tuesday. And then hopefully we are going to be really successful. Everything's going to make sense. And the way that I'm going to know that is I'm going to give you an online Google form quiz afterwards, which is I think 10 questions to really make sure you understand the basics, and then we're moving on. Okay, so we have 3 different vocabulary words that are super confusing: energy levels, sublevels, and orbitals. We are going to save orbitals because you guys, I got a lot of emails about orbitals. We're saving orbitals for later. So whenever we come back together, whether it be April or May or June, or if I wave to you next year in the hallway, we're going to save orbitals for later. So we're going to take that off of our plate because orbitals are super confusing for you guys, and they don't really mean anything for what we have to do for our next step. So we're going to save them for later. Okay, so what I am going to focus on is energy levels and sublevels and how they relate and how we can write the electron configuration. We're going to use sodium, which has 11 electrons, as our example, and then we're going to put everything together and write the electron configuration and talk about S, P, D, and F, and 1, 2, 3, 4, and 5, and how everything relates to electrons. Okay, so sodium is number 11 on the periodic table. So that means it has 11 protons, and if it's a neutral atom, it also means it has 11 electrons. So that number, the atomic number on the periodic table, we could assume is also the number of electrons for every atom that we're dealing with in this unit. So the nucleus is going to be in the center of our atom, and what we usually do is draw these rings around sodium just to say that these are where the electrons are going to be. This is our old model, and it doesn't really relate to our new model, but it serves as a foundation for us. So if I'm going to draw 11 electrons, what I used to be able to do is put this electron here and this electron here, 2 in the first shell, and then 8 in the second shell, and then 1 in the last shell to make 11 electrons. This is the old model, the Bohr model, the planetary model, and this is false because it really makes this electron look like it's going to go around the orbit or around that fixed path, and electrons don't do that. Instead, this electron right here is going to go all over here and all over here and all around here and all around here and all around here. So we really have to kind of get rid of this model and talk about how electrons behave and where they move. So we're going to erase this right now. We're still going to remember this and how it filled things up because there are some similarities. So again, what we're going to have is a nucleus in the center, and then we still are going to have our first 2 electrons be in this first shell, but instead of a shell, what I'm going to call it is an energy level. So what an energy level is a boundary around the atom where electrons move. So here, if we have 1 electron here and 1 electron here, again, 2 go in the first energy level. This electron can move all around here, all over here. This electron can move around here, all around here, all around here, okay? So it's almost like this 3-dimensional boundary around the nucleus where electrons move. That's what an energy level is. This is energy level 1 because it was the first shell that I drew. This is going to be energy level 2, and then this is going to be energy level 3. So as you get farther away from the nucleus, there are more energy levels. It just means the boundary of where the electrons move around in is going to be a little bit bigger. So if I had this 1, if you remember, sodium has 1 valence electron from our Bohr model. If I have 1 electron here, that just means this electron can go all over here and all over here and all around here and all around here and all around here, inside the 2 and the 3, but also doesn't leave this boundary. And that's called an energy level. And 1 is closest to the nucleus, 3 is farthest away. Okay, so we have energy levels. Now we need to talk about sublevels. So for sublevels, We have more specific regions of space within an energy level, because energy levels are big. It's the whole boundary around the nucleus. Sublevels are levels within the energy level where the electron is located, and they correspond to very specific shapes. So the first shape that we're going to have, I'm going to draw 3 principal energy levels again. So 1, 2, and 3 for our 11 electrons. We're going to have 3 principal energy levels. The first sublevel, the energy level, or the level within the level is called the S sublevel. So we have S. We are also, the next specific one is going to be called P, then we're going to have D, and then we're going to have F. And these, we're going to talk about how they apply to sodium, but they're actually really cool because the periodic table is organized by sublevels. The sublevels are S, P, D, and F, and the periodic table is organized by sublevels. So if you look at the periodic table, I'm going to draw just a rough sketch like this. Oh boy. Let's make this go over here. This is our rough sketch of our periodic table. What we're going to do is have blocks. We call them S block, P block, D block, and F block because they're just areas on the periodic table where those sublevels are organized. So this right here, these first 2 groups are the S block. Here, this is the P block all the way over on the other side. The D block is right in the middle. That's the transition metals. And the F block is down here, the lanthanides and the actinides. So it goes S, P, D, and F. That's how the organization on the periodic table works. The periodic table is also organized by principal energy level. So here, principal energy level 1 is the whole first row going across. Principal energy level 2 is this whole row going across. Then we have 3, 4, 5, 6, and 7 all going across. So here, what we can kind of do is treat the periodic table like a grid almost. So we can say like 2s or 3d or 4p, and we can really talk about where the electrons are located depending on what atom it is. So let's just talk about the shapes. So the S is a sphere shape, which again, we've been drawing sphere, so that's nice. It's all the same shape. The P is called, they call it a dumbbell, but it really looks like an infinity sign. So if you have, for example, a 2p sublevel, what that means is the boundary is going to be the 2, but then you have this like dumbbell looking shape, and the boundary is just the 2. And again, this shape corresponds to where the electrons move around the atom, around the nucleus. So here, there's going to be an electron in the 2p, and he just moves here, 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 all the way down here, all the way up here, all the way down here. Does this kind of make sense? A little bit? I know it's really confusing. The 2, the 3, the energy levels are the boundary where that electron can move. And the S, P, D, and F correspond to the shape that they move in. The D is a 4-point star, which is difficult to draw. So if I could do a 4-point star, say I want to draw a 3D, I would draw 1, 2, like this. And that whole area inside here, inside here, inside here, and inside here is where the electron moves. One electron can move in all 4 of these little lobe things around the nucleus of an atom. And then F, I'm not going to even try to draw it. It's called an 8-point star. Okay. And again, the S, P, D, and F, they're sublevels. They correspond to where the electron moves in a very specific shape around the atom. The 1, 2, and 3, 4, 5, 6, 7 correspond to how far away the boundary is from the nucleus of your atom. And that's what I need you to understand. And then we can take the S's and the P's and we can put them together and actually fill in the electrons. So if you have 2p, that still doesn't say what electron it is. So we're gonna back up, we're gonna not draw our shapes anymore, and we're actually just going to write the electron configuration for the sodium atom. We're gonna go back to our periodic table that had our blocks. Hope you can see this. So this was S, this was P, this was D, and down here is F. And again, we had 1, 2, 3, 4, 5, 6, 7 on your periodic table. So the order that electron configuration goes in is embedded on the periodic table. And so what we're going to do is write the electron configuration, starting off with the first electron and reading the periodic table like a book. And each column corresponds to 1 electron. So here in the S, there's 2 columns, so there's 2 electrons in the S. So at the S sublevel, I'll write it over here actually. The S sublevel contains 2 electrons. Always, always, always. It doesn't matter if it's 1s, 2s, 3s, 4s, 2 electrons, because there's 2 columns in the S block. This is the D block and this is the P block. The P block has 1, 2, 3, 4, 5, 6 electrons for the P block. So the P has 6 electrons. Always, 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 it doesn't matter if it's 3P, 5P, 7P, there's only 6 columns, so there's always 6 electrons in the P block, and the D is going to be 1 through 10, because there's 10 columns here. So every time you have D, it's going to contain 10 electrons, and the F, if you count them, there's 14 columns, so it's 14 electrons. So this is going to be 1 through 14, right here. Okay. So what we're going to do is almost think about it like playing Jeopardy, or not Jeopardy, Battleship. So if I take nitrogen, which is right here, nitrogen, which is right at the top, it's in 2, so nitrogen, if you look, it's the second column over, second row over, so it's going to be 2, then P, then 3. So nitrogen, if you treat the periodic table like you're playing Battleship, it's almost a grid going this way and a grid going this way. It's going to end with 2p3 because it's the second row, it's in the P block, and it's the third column over for nitrogen. Sodium, which we're going to do now, is going to end with, sodium is right here. Sodium is going to end with 3, which is the third row, the third principal energy level, S, because it's in the S block, and it's in the first column, so it's going to be 1. So 3s1. But we have to know how, like, where the electrons come from before that, not just where they end. So we're going to start off at the beginning and read the periodic table like a book going across. So the first thing that we come to on our periodic table is going to be 1s. And in the 1s, there's going to be 2 electrons, because in S, there's always 2 electrons. The next thing that we come to when we jump down, because there's no P in the 2, this is 2, so there's no 1 for the P. So this will be 2, 3, 4, 5, 6, 7. Next it will be 2s2. Right after 1s2, then comes 2s2. Then we'll go across to 2p6. Again, because in the P, you can always have 6 electrons. And then we're going to end with 3s1, which is right here. Because again, we've read across, now we're moving down 1 and going right here. So here, if you look at where the electrons are right here. The 2, the 6, and the 1 are the electrons. If you add up 2 plus 2 plus 6 plus 1, what are you going to get? Mental math, 11. And guess how many electrons we were trying to account for? 11. So the superscripts on your electron configuration always add up to the atomic number, which is the number of protons, but for a neutral atom is also the number of electrons. So the order is really important, read from the periodic table. It's important to know that this 1 corresponds to an energy level. That's the first row going across. This 2 corresponds to the second row, the second energy level, and this 3 is the third row going across. And the S's and the P's are different blocks on the periodic table, but also correspond to a different shape where the electrons are located. And then the superscripts add up to the number of electrons that you're trying to account for. Okay, deep breath. I hope that made sense. We're going to try to take a quiz now, and I hope you guys had a great weekend. I hope you have had a great start to your week this week. I hope you get outside today because it's not raining finally. And I cannot wait to hear your feedback and see you guys again soon. Okay, thanks a lot.